Welcome, my dear students. Now we see about analysis of beams. So beam is having three type of beams you are used. One is the cantilever beam, another one simply supported beam. So two cantilever beam is fixed one end, another one it is free. But simply supported beam supported by the two end. Another one moment is free. Okay, so next one, fixed beam is a two enders fixed with all directions. So this is a three type of beams. According to that, three type of load is available. One is, this is a point load with a cantilever fixed beam. So this is uniformly distributed load with simply supported beam. This is uniform varying load with cantilever beam. This type of beams, three type of load used in this fourth experiment. Okay, so what is the aim of this experiment? So first, to compute the shear force and moment diagram of for the beam shown and find the maximum deflection in the end of the beam. This is the determination parameters, and then we are assuming this beam is across the cross section is rectangular cross section 20 cross 30 mm, and then Young's modulus is 210 gigapascal, then Poisson ratio is 0.27. So this is the experiment of our experiment number 3B, analysis of one-dimensional element. Experiment. Now we can see how to draw the cantilever beam, supported beam, and fixed beam with point load, UDL, and uniform varying load. Okay, so this is the experimental things. So based on that, you are use the ANSYS software. Okay, students, we are going to how to solve this problem in ANSYS. First, you are going to the preference. This is a structural problem. You are selecting the structural category. So first, select the structural category, then give OK. Then preprocessor, element type, add, edit, delete. So you are selecting the add option. So then your problem is the beam problem. Your beam 3D finite strain 188 two noded problem. Okay, so 3 node means quadratic, 1 node means 2 node means linear. Okay, so now select this to blue color region. So after confirm this, you give the OK option. So then after adding this OK option, next close the option. Now we selection of beam element is over. Then real constant of the beam element. So this is a real constant. Add, edit, delete, add. Okay, so beam 188 no real constant. Then material model, then material so this beam is having isotropic problem. So same property throughout this beam. So there's a linear on elastic isotropic. The Young's modulus is 2 power 10 e power 9 gigapascal. Gigapascal converted into Newton per mm square. Poisson ratio is 0.27. Okay. Next, give the density. Density is for example 7860 kg per centimeter square. So okay. So material model is created. Then you have to section of the beam. The beam section is common section. Your section is a 20 plus 30, that is the rectangular one. So breadth is 20, height is 30. So this is cross section of the beam. After completing cross section of the beam, to create the model, create nodes in active coordinate system. First you have to apply 0 0 0. Okay, then the distance is 100 mm. Okay, to form a node 1 and node 2. Through this node to select a beam, auto numbering through nodes, apply node 1 to node 2. Okay, so this is the through node 1 and node 2 create a one element. So this is beam, and then after completing the modeling you are going to apply the boundary conditions. Your boundary condition is define loads. Go to loads and then define loads, apply structural displacement. Okay, one end is fixed, the node 1 is fixed. Okay, so apply all degrees of freedom. So this is apply the all degrees of freedom. Then you have to apply the load. So load is first one, load option is apply structural load pressure on the beam, pressure on the element. This is a pressure on the element. You can apply structural pressure on the element, on the beam. To apply, select this beam 1 to 1, apply. The pressure value is 0 to 50, 0 to jth node 50. Okay, can apply the pressure. Then have to solve the problem, solve until less. Okay, solution is done, close. Okay, now we are getting the result. Central post processor, plot results, contour plot, nodal solution, reform option, nodal solution, displacement the sum of vector. So I already told this already told the bar element. So deform shape with undeformed model. Okay, this is a maximum displacement at the end of the values. Okay, so 0.05 0.509 e power minus 7 of the end of the load. So this is the one end is fixed, the varying load. Okay, suppose I give the one end is rigid, another one is simply supported beam. Okay, so this is only one difference for this experiment. One is first we are going to the pre-procedure, load, define loads, apply displacement on nodes. For example, you are simply supported beam, you select this end to apply. So for only y direction you will support. Okay, so this node 1 and node 2 is only supported by only y direction. Okay, so this is the symbol of simply supported beam. So for a thing. Okay, next one, or otherwise you are going to the point load, structural force on nodes, apply. So for the y direction, load is constant value. So our load is 1000 Newton. Okay, for downward direction. Okay, minus, for example, load is downward direction. The symbol is for the downward direction for y minus 1000 kilonewton. Okay, so this is the point load of a cantilever beam, any method. Okay, so this is the general procedure of cantilever beam and simply supported beam or point load or uniform varying load, whatever it is. Okay, suppose you applying the UDL, so same thing. So structural pressure on beam, apply the varying from load 1000 Newton. Okay, so this is J and value is equal 10. Okay, this is a uniform distributed load. Okay, so this is the three different type of load, three different type of beams analysis in ANSYS. Okay, so this is the major part of this video.